Hi, this is Professor Monty. Let's talk about the algebra of functions. So we're going to let f and g be functions and x is a variable. So we can define f plus g of x. So notice what I'm doing is I'm adding two functions together. F plus g of x, those two functions added together, you can just calculate as f of x plus g of x. So it's just kind of how you would assume. It's really not the distributive property because these aren't variables, these aren't constants. They're functions itself. But to add two functions together and then apply to a variable is the same as applying each one individually to that variable and then adding the functions together. Subtraction works the same way. F minus g of x is just f of x minus g of x. Multiplication, same way. F times g of x times g of x, and then division, same way. F divided by g of x is f of x divided by g of x. Remember, as always, when working with the domain, if the denominator equals 0, it's undefined at those values. Okay, so we'll have to keep that in mind as well. But that's the idea of these functions. Let me show you some examples. I'm going to erase this. We'll just do some examples real quick. So let's find some of these. So let's define, suppose we let f of x equal 2x plus 1, and g of x is just going to be x plus 3. Okay, so now let's find some things. First of all, let's find f plus g of 5. Well, by the definition we just saw, that would be f of 5 plus g of 5. Well, what in the world does that mean? Well, f of 5 says you go to the f function, you plug 5 in where the x is. Well, there's the formula for it, so we plug in the 5 there. It's 2 times 5 plus 1. That's my first part. Plus g of 5, we go to the g function, plug in 5 where there's an x. 5 plus 3. And then we just work them out. So we get 10 plus 1, I'm just going to put 11, plus 8, and then 11 plus 8 is just 19. So f plus g of 5 is 19. That's going to be my answer. Okay, let's look at a second one. Let's do f minus g, but just of x. So we don't have a value that we're putting in, so we're not going to get a value out. We're putting in a variable. We're going to get a function out, a new function. What does the f minus g function look like? So we're defining a new function. Same two functions we're using. It's still going to be f of x minus g of x. Now we just do that. Oh, f of x is this whole function, 2x plus 1. Minus g of x is x plus 3. And notice we're subtracting that whole function. We have to distribute the negative in. So I get 2x plus 1 minus x minus 3. 2x minus x is x. 1 minus 3 is negative 2. That's my function f minus g of x. It's a new function. And it comes out as a formula. Okay, this up here was, if we write it, f plus g of 5. It was 19. Okay, so we saw those two examples. Let's do an example with the multiplication and the division. We'll do the same type of thing. So let's do maybe f times g of 1 by formula, f of 1 times g of 1. We're just going to plug them in. F of 1, put in the 1 there. 2 times 1 plus 1. Plus g of 1, plug in the 1 there. Oops, I said plus. It's times. 2 plus 1 is 3, times 1 plus 3 is 4, 3 plus 4 is 12. Again, that's g, f times g of 1. Okay, put in a number, get out a number. We'll do f divided by g of x. F of x divided by g of x. I'm going to write it this way. Well, f of x is 2x plus 1. G of x was x plus 3. There's nothing else to do there. That's my new function. That doesn't simplify. Notice x plus 3, the denominator can't equal 0. If I subtract 3, it says x can't equal negative 3. So my domain here would be all real numbers except negative 3. The rest of mine, I was never dividing by 0, so the domain is just all real numbers. But that's the idea. For the functions, addition, subtraction, multiplication, division work just as you would expect. And then if you plug in a number to the function, you just plug in a number, get out a numeric answer. If you plug in a variable, you're going to get a new function. So we're creating new functions from functions we already have. Okay, work with that. They'll get easier the more you do.